Lag 1 I/O System. Hi everyone, I'm Salas Rebecca from BSCPE 4102 at Vaslin College of the Philippines. For I/O system, these are the input and output. A computer's job is to process data. Computation, under of computation is the CPU, cache, and the memory. And the other one is move data into and out of a system between I/O devices and memory. And challenges with I/O devices, there are three different categories: the storage, networking, display, etc. Large number of devices drives to support. Devices drive run in kernel mode and can crash system. And the goals of a OS is provide a genetic, consistent, convenient, and reliable way to access iOS devices as drive independent as possible. And how does the CPU talk to devices? There are three ways. The first one is device controller, hardware that enables devices to talk to the peripheral bus. And the second one is the host adapter, hardware that enables the computer to talk to the peripheral bus. And the bus is the wire that transfers data between components inside computer. Devices control allows OS to specifically simpler instruction to the access data. Here are the examples. And for computer architectures, these are the examples. For compute hardware, there are three: the CPU and cache, chipset, memories, I/O hardware. Under of the I/O hardware is I/O bus or interconnect, I/O controller or adapter, and I/O devices. There are two types of I/O: programmed I/O. The under of the program is CPU does the work of moving data, and the second one is direct memory access or DMA. Under of DMA is CPU offloads the work of moving data to DMA controller. As you can see, for the programmed input devices, there are devices controller, a simple mouse design, and the input on a interrupt. And this one is the CPU, memory, and I/O bus, and the controller. And for the output program devices, these are the example. For devices, the status registers and the data registers. For example, a serial output devices, as you can see, guys, and the perform of an output. Under of the perform an output is a CPU. Call the BC bit, write the data to data registers or register. The set bit and controller set BC bit and transfer data. DMA stands for direct memory access. DMA controller or adapter, status register, DMA command register, DMA register, or DMA buffer. And host CPU inside DMA devices drives all. Wait until DMA device is free. Intimated DMA transition and the block. And controller perform DMA data to device issues, interrupt, or completion. CPUs interrupt header and wake up the block process. As you can see, the memory map I/O use the same address but to the address both memory and I/O devices. There are two the I/O devices, memories, controller, and monitor, address bus, and the orthogonal to DMA. Last, the polling versus interrupt driven I/O. Polling expensive for a large transfers and better to small dedicated system with infrequent I/O. Interrupt driven is overcome CPU, PC waiting, and I/O module interrupt when ready, or even event driven.